Welcome to a new video in my home automation and Node-RED playlist, and today I'm going to play around with WLED. I have been quite late coming to these addressable LED and LED light things, even though I used a NeoPixel display for my NR metric display, which is probably already about 2 years old. And finally, I purchased myself all the hardware that is required for this project. So first of all, I have a NeoPixel LED strip, and this is a LED strip which has individually addressable LEDs. It's this particular model, I think this is a 1 meter with 100 LEDs per meter. So this is 100 LEDs altogether. And as you can see, it gives a very nice pattern. And it is being driven using a Queen LED Dig Uno, which is this box here. And this is a driver PCB, which is designed by Quindor. And it uses a VMOS D1 Mini, and in that VMOS D1 Mini there is a firmware running which is called the WLED. I'm not going to go into the details how you can get the Queen LED Dig Uno, how you set it up and how you burn or how you flash the WLED, because that was already done by Quindor. And I also don't want to go into very details of the WLED because that is also explained. So I'm just going to leave a couple of videos and links in the video description so you can follow that. They are just really nice resources, and that's what I use also to get my project up and running. So I'm going to focus on how you can get this controlled using Node-RED. So I'm going to focus on a few test cases that I've created for myself. First of all, how you can get basic controls, change the colors, start effect, turning it on and off from Node-RED. And we are also going to look at it how you can use timers to start if you are using it as a Christmas light or some sort of night light, how to turn it at a specific time of the day and automatically turn it off. I also wanted to experiment if I can use this as an ambient light that would automatically adjust the brightness based on the brightness of the room. Next, I was thinking about if I can use this setup as a warning light. So let's say I have a lamp which is using this LED strip. Let's say I can use it as a normal lamp, but then it would change to specific patterns to indicate something. So like, maybe there is a pattern when an email is received or somebody rings the front door. So it would be like a visual feedback. So let's say for example, if you are listening to loud music, you wouldn't hear a doorbell, but you can use this light to give you a notification. And third, because the WLED firmware already provides Alexa support, but it doesn't have support for Google Home, I did the integration with Node-RED. Before we dive into the details, I just want to show you the two components that I used for this project, or the two additional components. For the timers, I'm using bigtimer. Oh, not this one, like this. So this is Node-RED Contriv bigtimer. And to control the WLED, there are actually two WLED components. One is called Node-RED Contriv WLED, and the other one is Node-RED Contriv WLED 2. And I'm actually going to use both of them because I think in some scenarios one works better than the other. And actually, if you are in the install page, you can click on these icons for both the WLED and the WLED2, because that gives you some ideas how you can control it. This page is well, not this one, but it's a little bit, especially for the WLED2, this page is much better documented than the info on the actual flow or the info on the actual node itself. So you can see all the different things that you can control. This one up here is a simple WLED, and as you can see, all you need to do here is give it a name and give it an IP address, and that's the IP address of the WLED. So as you can see, it is running here. So if I change the color palette, then the effect changes. And in the configuration, I have specified a fixed IP address for this device, so it is easier to control. But I think if you leave it on dynamic IP address, you can also refer to this device using the MDNS entry. So I could have specified, well, I haven't tested this, but maybe I could have specified WLED/uno.local in this case. But I think fixed IP is probably an easier way to go. So that's what I had to specify here. This one has a fairly good documentation, and it can do a couple of things. So based on the value that you send in, so if you send in a Boolean value, it's either a true or false, which I simulated with this button. As you can see, the payload is either true or false. Well, for on it's true, for off is false. Then it's going to turn on the LED, either turn it on and off. If you send in a number, then it changes the brightness. So I created a slider which sends in a number from 0 to 255, and that would control the brightness. If you send in a string which contains a name, that name is the list of the effects that are supported in WLED, and actually these are the effects that you can see here, then it changes to that effect. So I created a drop-down which has, well, I just picked a few effects, and it's going to send the words running, sparkle, or stream as a string, so that would change to that effect. And then finally, if you also send a string which actually contains a number, then you can go to one of the presets. So I have a few presets, and I've also created, preset 1, 2, and 3, and it would change to that preset. It is fairly simple, and the reason I like this node as opposed to the other node, well, for certain applications, because if you send in a brightness, then it's only going to change the brightness. It's not going to change anything else. It's not going to change the effect or the color palette or any of the settings. So if you want to change specific settings, I think using this WLED node is a little bit better as opposed to the other one. So, and if I show you the other node, which looks pretty much the same, it's, well, different color, and the logo is on the left, not on the right. And here you can set pretty much everything that you would also be able to set on the WLED UI. So you can change whether the device should be on, what is the brightness level, you can specify the three colors that are used by the effect, what is the effect speed, intensity. If you want to use one of the pre-defined palettes, you can pick it from here, and then you also have a preset, whether you want to use presets or not. And then there is a delay, so it is possible to start an effect, and after a delay specified here, it changes back to a solid color. So here in this node, you can set everything that you would otherwise set on the UI as well, and if you send any message in, it would automatically apply that effect to the WLED, or the LEDs that are being controlled. But also, in this documentation, you can see that if you send in a message which has specific properties like brightness, color, effect, then you can also override whatever you have set here with that value. And again, if you want to set a certain color or a certain effect that you, let's say, haven't stored in presets, you can use this one. But also keep in mind, if you are planning to use this to control the brightness, you can send in a message that would set the brightness, but that message would override the brightness that you set here, but it would still apply the same colors and effect speed and everything. So this is why I said that if you only want to change a specific value, for example, the brightness or the effect, without changing anything else, let's say the color palette, then you probably have to use the WLED instead of the WLED2. So I think you should download both of the nodes and then just use them interchangeably, depend on what you need. And let me talk about one last feature of the standard WLED. If we look at the documentation, you can see that if we send in an object, then we can control multiple properties at the same time. And if you go back to, again, the WLED, the user interface, you might have noticed that when you are creating a preset, when you open up the preset, you can see an API command here. So that's the JSON command that you can send in to this node to basically apply, in this case, this preset. And you might want to ask why I want to do that. I can just save a preset. Well, yeah, that's true. But again, if you look at this message, you can understand all the things that you can control. And actually, I'm going to use this functionality in one of the scenarios later on. And by the way, there is also a way to get the state of the device. So if you call the IP of the device /JSON/state, it's always going to give you a value back, which is going to give you the current state of the WLED. So you can see that it's currently on, the brightness is set to 127, the transition is set to 7, and there is loads of other things. And if you go into the actual API, which you can, actually you do have a link here, then it explains all the different values like fades and the various things on the segments are also defined here. Okay, but that should be enough just to get you started and get your head around what are the features available. Let's look at a couple of examples, because I think it will be just easier to, if we look through a couple of examples. So I've created a few UI elements. As you can see here, I have an on-off button, and this is the one which, sorry, not here, this is the one which is sending the true or false, and I'm just sending it here. And if you remember, if we are sending either a true or false, that is going to switch the device on. And as you can see, I can switch it on and off, and when I switch it on, I don't influence anything else on the device, so it will automatically come on to the same settings that it was used last time. Also, if I, sorry, wrong screen, if I control the brightness, then I can change the brightness of the LED strip. It may not come through the camera because it's on auto again, but again, that brightness is going to work regardless whether you are in effect or in a single color mode. So as you can see, I'm just sending the brightness value in as a number, and that will update the brightness as it is stated here. Next, you can also set an effect, so I can change between various effects, and that would obviously update the effect. It only updates the effect. Again, it doesn't change the color palette, so we are still using the same color palette. And the same you can do with the preset. So I can just call on preset number 2, which is a solid color, or preset number 1, which I save myself. That's going to be my preset for my Christmas light. And yeah, that's it. So if you want these, it would be really easy just to use a couple of UI nodes, which are specifically configured to send out a specific message. So for example, the name of the effect as a text, or the number of the effect again as a text, because if you send the numbers as a number, then it would be treated as a brightness change. The next one is, I was playing around with auto brightness. Let's say you want to use this light so it automatically adjusts the intensity or the brightness of the LED based on the ambient light. And you can do it in multiple ways, and you just have to figure out how you are going to detect the ambient light. I mean, there are a lot of sensors which have light sensors built in. I built a couple of sensors myself, so there is one outside which is measuring the like the sunlight and the ambient light outside. That's actually, I'm using that to control my blinds. But I also have a MeFlora soil sensor, which is measuring ambient light, so you can do that as well. So for the time being, I've only used a couple of inject nodes for this value, and I just picked some values from 1 to 1023, which happens to be the analog input value of the ESP8266. And you can put this through a range node, which I'm not using a lot, but as you can see, that can range your input value to an output value, or an input value to an output target. So I'm saying that, so if there is minimum light detected, then I set the brightness to 60, and if there is maximum light detected, then I set it to 255. So that would become brighter as the ambient light is brighter, so some sort of like display, so it dims when it gets dark. But if you flip the numbers around, so that's 255 and that's 60, then your light is going to automatically dim as it gets darker. So just to keep the general illumination in the room in a constant level depending on the outside light coming in. And because this just generates a number, we can just send it in, and that will control the brightness, and that would control the brightness to whatever effect or color which is displayed on the LED at the moment, or the WLED at the moment. The only thing you have to be careful about, because if you, let's say if you turn it off and if you modify the brightness or change the brightness, that automatically turns the light on. So when you set a brightness value, it turns it on. So what I have done here is I've created this simple function node where you can send in a message, and that message has to have a specific topic. So the topic has to contain either on or 1 or 0 or false, on or off or 0 or 1, and that would turn this function node on and off. So you can control whether that allows the messages to go through or the messages not to go through. So the idea about this one is that if you have a setup, so for example, if you are controlling your LED, you also divert that control signal or the power signal to this function node, so that would stop the brightness value going through, so it would not automatically turn off or turn on when it's otherwise off. Next one is the evening lights, and for that I've used the bigtimer. And of course, here in the bigtimer, I said that I want my lights to turn on at dusk and turn them off at 11:45 p.m. And for that, I should actually specify my latitude and the longitude, otherwise the dusk calculation isn't going to be correct. And that would create a message which contains the text on when it's dusk, and it's going to contain the message off when it is the switch off time. And with this message, I can just put it onto a simple change node, and then depending whether it's on or off, I can divert the message. And if it's on, I can, for example, send in a string 1, which is going to call up preset 1. So it's going to turn the lights on at preset 1. And if I want to turn it off, I just set the preset to false. And we just learned before how you can use these values in the WLED node. So yeah, it's going to turn on the lights at preset 1, and it's going to turn it off. Just one thing about the bigtimer node, that when you place it by default, these two checkboxes are going to be checked, which means that the output is going to repeat it every minute, and also it's going to output on startup. And just be aware that if it's going to repeat every minute, that would mean that for every minute when the light should be on, it's going to send a signal to turn on. So if the light turns on and if you turn it off manually from the app or from the website, then the next minute is going to turn on automatically because it's repeating the output. It does it every minute. If you don't want to do that, you can switch this one off like I did. And if you haven't used bigtimer before, one thing you can do also with the scheduler is you can send in a few different messages. So if you want to test the node, you can just send in a message which, let's say, the payload contains test, and based on the actual state, like whether it's after dusk or after 11:45, it's going to send out the proper message that it needs to. You can also send in a message which contains on, and that's going to override the settings here, and that will just turn the lights on. You can do the same with the off, and then it turns the lights off, as you can see here. And you can also activate the scheduler so that it automatically returns to the same state as it's specified here by the the timer settings. And by the way, there are tons of other settings here. It's just go through this, and I'm pretty sure you can use bigtimer to whatever automation settings that you need or light settings that you need. So that was the evening light scenario. The next one, let me just turn the lights on again. So the next one is a visual warning. So for that, the idea is that you have this light which is, well, it's either turned on or turned off, but I want to use this light to give me a visual alert that something is happening. Let's say I've received an email, somebody rang the front door, I got a tweet, anything I want. So I can learn, let's say, a couple of visual patterns, and then if I see that, I know something is happening. So if I have my headphones on or I'm listening to loud music, I will still be notified that something is happening. I need to pay attention. And that's what this visual warning flow is doing. And for this, I've used the WLED and also the WLED2 node. And in the WLED2 node, I specify what is my visual alert. So here I specified my visual alert, which in this case is, well, the light comes on, obviously. I set it to medium intensity, and I picked red and blue. and I wanted these lights to blink, and I increased the speed so it blinks a little bit fast. So what I want to do is when this alert happens, I want to turn on this effect, and after, let's say, 10 seconds, I want to return to whatever state the device was on before this alert came. And this could be another effect, like for example now, or maybe it could be the fact that the device was turned off. So what I did is the information comes in that I need to start this visual warning. I call the /JSON/state URL of the device. So just don't forget to update the IP address here. And that would give me the current state of the lamp, like, you know, what state the lamp is before I start my new visual effect. And then next I just empty the message.payload. So I just send an empty message into the WLED2 node, which is going to apply the settings that you see here on the screen. On the same time, I also send this message to this function node, which is going to store the actual value in the context. So that's how it remembers what was the state before the new effect got applied. And I also send in the message to a delay node, and that's going to create my 10-second delay, after which I want the light to return to the original state. And after the 10 seconds, I just change the topic to recall, and I push that message into the same function node as well, which knows that if it's a recall topic, then it actually needs to get the previous state that got stored 10 seconds ago, and it sends that JSON into the simple WLED node. And this is what I mentioned a couple of minutes ago, that if you get the JSON of the JSON.state and then you send it into the WLED node, you can actually reset that state to the controller. So let's see how it works. I actually have to trigger it from the dashboard. Let me do it this way so we can see the messages going back and forth. And I just need to find the, where is it? Blink warning. So you can see the new blink is done, the delay is being executed, and then once the 10 seconds expires, it should return to the previous state, which it just did. And it works the same way if the lamp was off. So it's going to turn on with the blinking red-blue pattern, and then after 10 seconds it's going to turn off. So I think this is actually a great way of doing these visual alerts, and of course you can just copy and paste this flow as many times as you want, and you don't have to change anything here. I've written all these function nodes and everything, so everything is self-sustained. The only thing you need to update is in this HTTP node, just update the IP address, and of course update the IP address in both of the WLED nodes as well. And then it's going to work, and you can have multiple of these. Probably the only thing to keep in mind is if you send in too many messages at the same time. So if you send 2 messages within the 10-second period, then of course the second message is going to save the state which was set by the first warning. So that's it never going to return to the original state of the LED. I hope you understand what I mean. But still, I think for like irregular sort of messages, it's going to work just great. And finally, we arrive to the Google Assistant integration. As I said before, there is an Alexa integration already built in. So it is under Sync Interfaces, and you can see the Alexa voice integration here. I don't have an Alexa, I don't know how it works, so I'm not going to show you that. So, and that's why I built the Google Home integration, and I think it does pretty much like what the Alexa integration would do. So you can use voice commands to turn the lights on and off, and you can also control the brightness and the color. Of course, Google Home doesn't have a concept of effects, so you can't control that using Google Home. But actually, I do have a workaround for that, so I'm going to mention that right at the end. So the core of the flow, or this part of the flow, is a light node from Nora. So you just have to configure Nora, and you give it the light a name. You also provide what room it is in, and you have to allow brightness control, color change, and also RGB support. And if you put some debug notes here, you will see that every time the light is updated in the Google Home application, or by one of the Google Home devices, it's going to send out some information which is going to control whether the device is on, what is the brightness, and what is the color value, which is in H, so hue, saturation, and V value. And that obviously needs to be converted to RGB. But let me just show you how it works. So I just need to find my room. Yeah, it's here. I have a couple of lights on. Oh, actually, this is the, let me change the WLED. Okay, so at the moment it's on and it's set to 49%. So I can turn it off from here, and then it's going to turn off. And I also can turn it on. It's not going to turn back on to the effect because, well, Google Home doesn't have a concept of effect. So I just programmed it so it turns on white. But as you can see, you can control the brightness. So I can take it all the way down or all the way to the top. And I can also change the colors. So that's one color. That's another one. And I can set it to blue as well. So yeah, nothing awfully complicated, to be honest, here. And this is what you get in the user interface. And of course, you get the same functionality over voice as well. So you can just say, set the WLED to 81%, and it's going to do, and Google Home is going to do that. So that's what this part of the flow is responsible for. So the message that comes out from the NORA node, it is being converted to the format that is used by WLED. So I'm just using the conversion of the HSV colors to RGB, and I'm also setting, the state and the brightness values, and I'm actually pumping that out to the WLED2 node. So it doesn't matter what you set here, because all the settings are just going to come through the function node, and it's going to fed through the specific topics that are mentioned here in the documentation. And I've actually done the same if you want to use the WLED node as well. You just have to connect it from here. So that it does that one. So it creates the integration from Google Home or from NORA all the way to WLED. But I can do the other side as well. So let's assume that something changes on the WLED side. So if I go here and I just modify the brightness, and let's say I just still keep it on, then if I trigger this node, that's going to get the status from the WLED, and that's going to send the update to the NORA and also to Google Home. And probably you can see now that the value got changed to 8, which is the 8%. So integration works both ways. And I mentioned in the beginning that there is no way to set scenes, but actually I think there is. Well, there is a workaround, because if I look at the NORA nodes, I can just create a simple light. Let's say, this light doesn't allow brightness control, so it's a simple on-off light. And you can give this light a name. So I don't know, color waves. This is the name of one of the effect. So it's going to send out a true or a false, whether it is going to whether it's turned on and off. So what you can do, you can feed this in a very similar flow that I've used for the bigtimer. The only difference here that one of the output is if it's true, or the other one if it's false. And then, if it's true, so the light got turned off, then let's say you can call a preset, and then you send it to the WLED node, or you set it to false, and again you send it to the WLED node. So the effect is going to appear as a different light in your Google Home app, but you would still be able to use the voice command to say, please turn on the color wave lights, and then your WLED is going to come on with a specific preset, which is set to, let's say, an effect that you like. And then you can have a couple of these. I'm guessing you're not going to create, for all 100 of the effects that you have, but you do probably have a couple of favorites that you can save as a preset, and you can just call up those presets using these, pseudo lights that are going to appear in your Google Home app. So I think that would be my take on how you can integrate WLED using Node-RED. And for that, I haven't even used MQTT because there is an MQTT functionality here. Under sync interfaces, you can see the MQTT support here, which actually I configured it for my MQTT server, but I realized that I can do pretty much everything I want using the WLED nodes and with just a little bit of HTTP request. So yeah, I'm not going to use MQTT for WLED for the time being. And just like before, you are going to find the link to this example flow in the video description, and also I'm going to include the links to the useful videos that I use to set up my WLED, to understand how the WLED works, and also how to set up the Queen LED Dig Uno that I'm using to purchase this light strip. I think that will be all for today. Thanks for watching, and hopefully see you in the next video.